Perpendicular lines are the ones that intersect at a right angle. So if I had two non-vertical lines and I wanted to say they were perpendicular, that can only happen if the product of their slopes is -1. In other words, if I multiply m1 times m2, then I'm going to get -1. Or we can think of this as they are negative reciprocals of each other. Okay, so let's practice this. I want to find the slope of a line perpendicular to this slope. Okay, so if this is my slope, if m is equal to 3, then the perpendicular slope would be -1/3. Okay, the negative reciprocal, remember that if I have the number 3, its reciprocal is 1/3. We kind of picture this as being an imaginary 3/1. So its reciprocal means I just change its place from the numerator to the denominator, or I switch it. And now for perpendicular lines, we're saying negative reciprocal. What happens if I multiply the number 3 times its negative reciprocal? I get -1. Okay, let's try again. My slope is -2/7, so my perpendicular slope is a positive 7/2. Just take these numbers, switch their places, and change the sign. Okay, so that's how you find perpendicular slopes. Remember that this little symbol right here, that's a right angle symbol, so that's perpendicular. Okay, now I want to be able to determine whether two lines are perpendicular. First thing I want to do is to make sure the equations are in the slope-intercept formula. The key to parallel and perpendicular lines is evaluating their slopes. So I want to put it in the y-intercept formula, slope-intercept formula, so I can identify the slope. If the slope of one line is the negative reciprocal of the other, then they are perpendicular, is basically what that says. Alright, so let's practice. This example, all I'm wanting to do is to determine whether or not these two lines are perpendicular. Okay, so let me write that up here. Are they perpendicular? Okay, so this is already written in y equals mx plus b. So if I wanted to identify the slope, okay, the slope is 3 of this line. I'm not concerned with the intercept. I'm only concerned with the slope of this line. The slope, not y. The slope of the second line is 1/3. Well, is m1, if I multiply m1 times m2, do I get -1? No, because 3 times 1/3 is +1. In other words, 3 and 1/3 are reciprocals, but they are not negative reciprocals. So these are not negative reciprocals. So they're not perpendicular. Okay, let's try again. How about these two lines? Here, these equations, remember these equations are written in standard form. They're not in the slope-intercept form, so we're going to change them. Step one says, let me make that clearer for you. Step number 1. We want it to be in the y is equal to mx plus b form. Okay, so let's change this one. I'm going to subtract 4x from both sides. I get -3y is equal to -4x plus 7. I'm going to divide both sides by a -3. y is equal to negative 4/3 divided by, negative 4 divided by negative 3 is a positive 4/3 x. Positive 7 divided by negative 3 would be negative 7/3. We can leave it like that. Okay, let's do this one. 8y is equal to negative 6x minus 5. I'm going to divide all my terms by 8. So y is equal to negative 6/8 x minus 5/8. Now let's rewrite this fraction reduced. So y is equal to negative 3/4 x minus 5/8. I now have the first line and the second line written in the slope-intercept formula. So let's move on to step number 2 and identify each slope. So the slope of this one is 4/3. The slope of the second line is negative 3/4. Well, 4/3 and negative 3/4 are negative reciprocals of each other. And I can prove this by saying m1 times m2, it equals negative 1 if I say 4/3 times negative 3/4, right? 4/3 and negative 3/4. Well, sure enough, I get negative 1. Okay, so in other words, these are perpendicular to each other. They are perpendicular. Okay, so that's how you can identify. The key, like I said, put it in slope-intercept form and evaluate or identify what's going on with their slopes of the lines.